Writing Blazor apps is all about components. They are the building blocks for pages and page elements. Creating simple components has already been covered in the introduction video, but many advanced mechanisms are available to cover complex scenarios. The child content parameter enables components to handle nested elements. Using additional parameters of type render fragment, parts of components can be templated. It is even possible to generate render fragments dynamically with the help of the render tree builder, and cascading values provide cohesion for hierarchies of rendered components. For the upcoming demo, I will implement two components that utilize functionality from Bootstrap. As a first example, I create an alert component. Showing an alert in Bootstrap requires a piece of HTML that looks like this. There are two parts in this snippet that should be dynamic. The most obvious part is the content of the alert, and the second bit is the alert primary CSS class, which can be replaced by one of several other supported classes. I add a piece of code to the component to support an alert type parameter using an enum. The choice of an enum has pros and cons here. On the one hand, it offers type safety. On the other hand, it requires maintenance if Bootstrap changes to support additional alert types. This implementation is just an example. My code includes a property alert class that uses the assign type to render a string representing the required Bootstrap CSS class for the alert. I replace the specific alert type in HTML with the alert class property. Now I need to take care of the content for the alert element. Blazor supports scenarios like this out of the box, using a parameter with the standard name child content. Since this content can be anything from a simple piece of text to a complete HTML snippet, the parameter also uses the special type render fragment that is meant specifically for this purpose. I replace the text in my HTML with the @childContent property reference. Now I can show an alert on the main index.cs HTML page. I run the application, and the alert comes up correctly, using the standard primary background color. I make a small change by assigning a different type. I build and reload in the browser, and the alert changes to the warning background color. I'll take things one step further with the alert component and introduce a title parameter. I change the rendering to display this title using the CSS class alert heading, but only if the parameter has been specified. This shows how elements can be handled flexibly during rendering and output vary depending on circumstances. I add the title attribute to the alert in the index page. And it shows up as expected at runtime. For a second sample, I've now created a similar implementation using the Bootstrap card component. As you can see, the title is rendered using an H4 element by default. It's possible to include template properties for the component that allow certain parts to be overridden when the component is instantiated. I add the property title template for this purpose, using a generic render fragment type. As you'll see in a moment, this means that a title template sub-element needs to be included to customize the title. This isn't compatible anymore with the automatic child content mechanism I showed earlier, so I rename the child content property to content. Now I replace the simple rendering of the title with a more complex block that uses the template if it's been specified and renders the complete block conditionally. At this point, the card can be rendered with or without a title template. I add a block to the index page to test the default behavior. In the Running app, the card comes up with the default H4 title. Back in code, I add a title template block that uses an H1 element instead and assigns a different font color. Note that because I used the generic type render fragment of string for the parameter declaration, the template receives a string value when it is rendered. By default, this value is available using the name context. By setting the context attribute on the template block, I change the name of the variable to lowercase title, and I use it to render the original title in the correct place in the template. I rebuild and reload, and the card now shows the title using the custom template. This simple templating mechanism is useful wherever you have individual blocks that benefit from a template customization option. I add parameters for a card header and footer. Then I add blocks to the HTML to conditionally render these templates. They don't have defaults, so they are only included if their respective template blocks are specified for the component. To check the behavior, I add header and footer blocks to the card. At runtime, everything comes up as expected. At this point, I have a card implementation that covers several specific customization scenarios. However, some functionality of the Bootstrap card component is not covered. For instance, Bootstrap supports multiple card body elements in a single card. I need to implement parent and child components individually for these use cases. I've created a new demo solution, and I quickly add individual components for the card itself. As well as the header, footer, body, title, and text elements. These components are all quite simple, made to render one card element at a time. Of course, it would be possible to use template mechanisms for customization purposes as required. On the basis of these components, it is now possible to construct any Bootstrap card by combining the elements. I add an example to the index page and show it in the browser. The structure I created is very open and flexible, and it's easy to see how CSS frameworks can be represented by components using this approach. However, there is one big issue with such an open structure. The parent component does not control the overall rendering process anymore. It would be possible to specify the individual parts in random order, add multiple headers or footers, and break the intended structure of the component in other ways. Of course, all this is equally possible when working directly with the CSS framework, but it should be an advantage of a component structure to provide improved usability. The following demo shows how this can be done. I've now opened a prepared solution that introduces several new concepts. First, a look at the index page. You can see that a card is created here, with various sub-elements representing the card header, footer, and body. The body has its own sub-elements for text parts, a title, and links. Note that I've added the sub-elements on both levels out of order. For instance, on the top level, the second card body follows the footer. And in the first card body, the title is the last element shown. I did this on purpose to demonstrate that the implementation handles the logical order of elements automatically. At runtime, you can see the card footer appearing at the bottom and the body titles above their respective content. Back in Visual Studio, here is the implementation of the card component. The first new element you see is the cascading value tag near the top. This tag provides a value to all child components nested inside it. There are many use cases for this mechanism, and I'll demonstrate this in more detail in a future video. In this case, the value provided to the child elements is this. In other words, a reference to the parent component itself. In the @functions block below, there are 3 helper methods: add body, set header, and set footer. Using the reference to the parent component, child elements can register themselves with the parent using these helpers. Back up in the HTML block, the card component uses the configured children to render specific blocks of the overall content. As a result, a given header always appears at the top, a footer at the bottom, and the body elements in between. In contrast to the previous demo, this setup allows the parent component to remain in full control of the rendering mechanism. To implement the child components efficiently, I created several base classes in this demo. Here is the class childElementOfT. At the top, there is a property with the attribute cascading parameter. This is the opposite side of the cascading value tag I pointed out in the card component. The child component automatically receives the reference to its parent in this property. The onInit lifecycle method is called by Blazor when the component is initialized, and it's used here to register the component with its parent. The final important element on this level is the render content property. This is how the card accesses the content to render for each child. It is implemented in the various derived types. I bring up the card link as an example of a component that derives directly from childElementOfT. As expected, it implements the register method to call the specific parent helper relevant for this type. The abstract property renderContent is also implemented here, and this is the second new concept used by my implementation. The render fragment is created dynamically using methods on the type renderTreeBuilder. The implementation for the card link is not very dynamic, but here is the component container childElementOfT, where you can see that the wrapper tag is generated dynamically depending on a setting that uses the element type enum. Dynamic creation of render fragments is a very powerful mechanism in Blazor that covers many complex use cases. Using the base classes I've created, most child components are implemented using just a few lines of code. Here is the card footer, for example. It derives from the container childElementOfT you just saw, and it contains only 2 specific overrides to handle its registration and to set the correct CSS class for the element. This concludes the overview of a more complex implementation of Blazor components. You've now seen most of the mechanisms relevant to Blazor component structures. Feel free to download the demos and test everything for yourself. That's it for this video. Make sure to keep up to date with all of our YouTube content by subscribing and ringing the bell. Thanks for watching.